Okay, so far we study in three-dimension space. Okay, this is three-dimension space. We study different objects, mathematical objects. We study a point. A point is an object que contains dimension 0. But the dimension of the point is 0 because the point have no length, width, nothing. So it's equivalent to say degree of freedom 0. After we study line, one line the dimension is 1. Because we have only one dimension, no? In this direction or in this direction. We have no in the other direction. Plane. Plane have dimension 2 because we have the degree of freedom 2, no? This is degree of freedom 1. Because we were moving in that direction or in this direction or in this direction. So this is a plane. We study also a sphere in the first lecture. A sphere is non-linear. A sphere is a ball. It's a three-dimensional ball. Let me try. Okay, a sphere. Okay, no good sphere. A sphere is non-linear because the equation for the line, the equation for the plane, the exponent is 1. That is the reciprocal linear. Everything is flat. This is part of the linear algebra, no? This everything is flat. But in calculus, no, we have a surface. This is surface. A sphere is, let me explain and detail this. We have two possibilities, no? Surface, or we have solid sphere, no? When it's surface, it's only the skin of the sphere, so the peel of the sphere. And this is two-dimensional object. When this is surface, it's dimension 2. However, si es solid, it's a ball. It's a ball, entonces it's dimension 3. Okay. And now, from now, we study the interaction relationship between these objects. There's a line and point, a line and plane, point and plane. And after when you finish everything, we study another family, important family of surface. Not only a sphere, no, another family of the surface, but not today, I suppose. Okay, so now let's move on to the point and line. So point and line. So we have one problem that contains one point and one line. Okay, one point, let me call P, and one line, let me call L. Entonces basically they want to know the shortest distance between the point and the line. Es obvio que the distance is one segment que es perpendicular to the line. Of course, it's 3D. So now, so you see, for example, lateral view. In the lateral view, you have the line as a point. So suppose this is my eyes. You see only one point, and you have another point. And this is the distance. Okay, I try to find. Okay, D. Let me call D. Okay. So there are different ways to compute that. We have one method that I call the book called different slider method. And we have another method that is the projection. Projection method. Let me discuss the basic idea. The basic idea is relatively easy to find one point on the line. Let me call A. And when you have that point, we will be able to find the vector connecting the point and this point. But in this case, I have the parametric equation of the line. So now, this point, que es slider, is, it's variable. So you move t, this is for t equal maybe 0, maybe it's t equal 1, so it's another vector. Okay, entonces we can move, pero move until you get this, the condition, que es que the vector AP the product but the vector direction of the line, que this vector, vector direction, not necessarily univector, is one vector que indicate direction of the line, is equal to 0. And this is orthogonal. This is one possibility. Another possibility, que personally I like, is projection. I want to do both ways. In this first example, after I using projection anytime, is pay attention. I need to find this distance. So remember, we have two kinds of projection: horizontal projection and vertical projection. Okay. And remember, when you're talking about projection, the mathematical of the projection involves univector. So the only possibility you find the univector is the univector in the same direction of the direction vector of the line, no? And the only possibility. So you find the univector of the direction vector of the line. Okay, now when you perform, so when you have the univector and you perform, for example, a dot product, you compute this component, the blue component. And the blue component multiplication, no dot product, regular multiplication by the univector in the same direction of the direction vector of the line, give me this vector. But this vector is not the vector I am looking for. Okay, but you find the vertical projection, subtraction, p vector minus this vector blue, and you get that. As you find the magnitude of this, then you get the famous distance, no? Okay, I'm looking for. It's a one possibility, but look like too long. So in my opinion, much better do the cross product. Let's say you perform the cross product, AP. Cross product, of course, we are talking about projection. Projection is univector. You perform, for example, the cross product with B. Of course, magnitude. And divided by magnitude of B, you get the famous distance, right? Why? Because I know very well the cross product is the multiplication, the two vectors. So this is famous theta, is the angle, right? And this is somehow connecting by sine theta. Sine theta. So this is the challenge, guys. Is in some problem you apply vertical projection, and other you find horizontal projection. How do you know that? Well, in this example, point line, the distance I try to find, is the red one, is perpendicular to the vector, direction vector, is the only information that we have in my hand. Therefore, in my opinion, the best way is perform the cross product, okay, and between, of course, the distance is well, cross product AP, pero cross product with the unit vector of the vector P. You can do it that way, or you can do directly in that way. Sometimes it's easier because you know when you compute the unit vector, the number, I don't know why, look like complicated. Entonces, our arithmetic complicated. Entonces, my recommendation is do before the cross product, so like that, first, and divide by magnitude this, and you get the shortest distance between the point and the line. By curiosity, only the first time we are doing a slider method to understand, because some people lie, I don't know, and projection, que in my opinion is most important. Keep in mind that not always is this in that way. Sometimes is cross product or dot product. That depending of the position of the segment distance you try to looking for and the vector you have in my hand. In this case, they are perpendicular because B vector is perpendicular to the segment distance, therefore is cross product. Pero en another example, que I promise in a few seconds you see, es paralelo. Entonces, si es paralelo, entonces much better dot product. Okay, let's try a slider. What is the idea of the slider? Let's put number here to understand much better. Suppose that we have a point. One point is given. Que ese point P, que es 4,4,1. And one line is given, line. Of course, it's given the parametric equation, no? X is equal to t plus 1, yeah, plus 1. Y is equal minus t plus 7, and z equal 80 plus 5. As always, this line is infinity in both directions. T is from negative infinity to positive infinity. This is domain. Okay. So now, let me try to make a sketch. Hypothetical, not exactly the same sketch that we can do in algebra. Hypothetical to understand the idea. This is the point P. This is the distance I try to find, D. I select one hypothetical point A. Doesn't matter if it's capital or lowercase. You compute the vector AP or PA, AP. Remember the convention when the arrow point to this is AP. So now, how you find that? Bueno, I suppose that the point A, que is defined by this parametric equation, have associated one position vector, que is the position vector doing by this coordinate, no? This equation. So see, I want to find AP vector is. You're subtracting. Let me do the arithmetic part here. You're subtracting who? You're subtracting 4, okay, the first component, minus this expression, 2t plus 1. This is minus 2t plus 3. So this is my first component. Minus 2t plus 3 is the component x for the that vector. The second is 4 again, it's a coincidence. Minus paréntesis minus t plus 7, ¿no? Es obvio que es t minus 3. O sea, t is cancelled, o sea, distributed. I don't want to explain the algebra here, you know very well. Entonces t plus 3, comma, and the z bar is 1. Look, c is 1 minus this expression, que es 80 plus 5. So give me minus 80 minus 4. Okay, minus 80 minus 4. Okay. Now, remember our direction vector B is the vector 2, comma, negative 1, comma 8. Where come from this? Well, this is the trigonometric equation. Oh, let me see. Yeah, you are right. F minus. Thank you. F minus. F minus. T minus. Thank you. I have in my paper. I don't know what is the reason they copy wrong. Okay, now, do you understand now? Okay, the direction vector is this number, no? Que es 2, negative 1, 8. Que es in the parametric equation, the coefficient in front of the t, no? Is the direction vector. So you perform the cross product, AP. A cross product, no. Dot product, B vector. And you enforce it to be 0 because at this point is orthogonal, 90 degrees. When you get the equation, no? And this equation you solve for t. Let's do it. I multiply this times this. You multiply this times this. You multiply this times this. So I want to skip the algebra. I see that the answer is 69. But let me copy here. 69 t plus 23 equal to 0. The answer is 69. So this equation is derived like that. 69t plus 23 equal to 0. And you solve for t. Entonces t es igual a 69, t es igual a minus 23, divided by 69 both sides, t is negative 1/3. Okay, now using this parameter t equal negative 1/3, I suppose que es t in this point. And t in this point is negative 1/3. Use substitution in the vector. Okay, use substitution x is equal negative 2, parenthesis, negative 1/3, plus 3, and the answer is 11/3. Y is equal, t que es negative 1/3, minus 3, que is negative 10/3, and z is equal minus 8, t que es negative 1/3, minus 4. And the answer is negative 4/3. This is the component of the vector AP, no? And this exactly position gets perpendicular. Now the rest is compute the magnitude of this vector in this point. The magnitude pretty easy, is square root 11/3 squared plus negative 10/3 squared plus negative 4/3 squared. This is too long arithmetic, but it's okay. It's square root 237/3. Okay, this number don't give me too much information. What is the distance? However, if you convert to decimal approximation, you have some idea how it looks like. It's 5.1360. And this is the shortest distance in between the famous point and the line. This is the slider method, in which you suppose that the point A, so remove in order to say you get the minimum when the dot product is 0 because of orthogonal, perpendicular. Okay, this is easy or no? Yes or no? Another possibility, another possibility of solving this problem, personally I like, is using projections. And projection, remember, we have horizontal and vertical. But in this case, it's much better vertical because I want to repeat this idea. It gets a little bit hard to understand. No, in this problem it gets easy, it gets more complicated. The segment I try to find is perpendicular to the vector direction of the line. This idea suggests us that we're using the vertical projection. And vertical projection involves a cross product. Basically, I try to find the cross product, pero no in the literal. Okay, no. You select, for example, arbitrary point A. Okay, let me try here. You select arbitrary point A, but no generical point A, like a slider. No, one specific. And this specific is, for example, I take the point 1, 7, and 5. Wow, where I come from that number? Well, I take in the parametric equation of the line, I assume t equals 0. No, you assume anything. And the easiest suppose t equals 0. So basically, you take that number. And this is one specific point. Entonces, now, in order to find the vector AP vector, you subtracting that component 1, 7, and 5, minus P. O sea que you consider ese point, pero you consider que let me copy P. Who is P? Bueno, P is 4, 1, no? Associated with that, of course, we have position vector, no? Entonces, ese point, pero we can consider it. Entonces, you, in order to find the vector in between 2 point A and P, you're subtracting. You're subtracting 4 minus 1 is 3. 4 minus 7 is -3. And 1 minus 5 is -4. I know that in this position, AP is not the shortest distance. However, when you perform the projection, so you perform now AP, vector, cross B. So basically, is or either way, P cross A. I don't care because actually the only difference in between this guy is the sign. But after I need this time to say you compute the actual value of this, actual value of this, actual value of this, actual value of this, actual value of this. Suppose que es the B vector is this. Is 2, -1, 8 cross product 3, -3, -4. And also you find the actual value of this, no? That's it, no, because when you compute the projection, remember, you need to divide by magnitude. So basically, the thing that we are doing is no cross product with B, the unit vector of B. But in order to don't complicate too much this arithmetic part, you can separate. You divide by the magnitude of the vector B. So you divide by magnitude vector 2, -1, 8. Okay, by the way, I want to do now, because it's relatively easy, no? Is magnitude vector B is square root 2 squared, que 4, 1 squared, que 1, and A squared, que 64. And this is square root 69. Ooh, ugly number. Suppose you introduce the square root 69 inside the cross product, so it's more complicated our determinant, no? Bueno, I recommend something, guys. I recommend to avoid the arithmetic part. This is square root 69. We using, so the online they are, well, GeoGebra is possible, but the only disadvantage in GeoGebra, well, in GeoGebra is good. Oh, I want to illustrate another way, is using Symbolab. Symbolab is one software. Let me show you. Let me share the screen with the Symbolab. Symbolab. There you go. Now let me see. Yeah. Do you see Symbolab?
Yes.
Yeah. Okay. Because I'm going to save time. I do that. So I use select vectors, so matrix, specific the section for the matrix, the section with the vectors. Here I put the number, no? This is the vector AP, and the position determined it was equal 0. 3, -3, -4, cross product. You select cross product, cross. 2, -1, and 8 is the B vector, and you perform the cross product, and the answer is -28, -32, and 3. Okay, entonces I avoid determinant, okay, because I have something more important to do in this. So basically is the vector, okay, let me copy here. The cross product 2, -1, 8, cross product 3, -3, 4. The answer was -28, -32. I don't remember if I put in that order or I put in opposite order. So you use interchange this. The answer is the same except the change the sign. But I want to find the magnitude. I want to find the magnitude, not necessarily. It's important. So in order to find the magnitude, you compare the square root -28 squared plus -32 squared plus 3 squared. Okay, and this is calculator, you know, is square root 1817 divided by square root 69. And this is, when you put in the calculator, is square root 237 divided by 3. It's exactly the same value, 5.1316. Okay. So now advantage and disadvantage. Well, see, I try to write one formula for this problem. And the formula is easy. The formula is the distance, the shortest distance is absolute value B vector cross product AP vector divided by magnitude B. Okay, esa formula in the story. Entonces, what is the A? Well, A is completely arbitrary point on the line. P no, P is given. You see, one professor I like both ways. However, in other problem, we have two lines, and you make a decision doing by slider. Entonces it's more complicated because you have two sliders. One slider travel in one line, and another slider travel in another line. After I want to show you, no? But it's complicated because we have two equations, and you have two parameters, not only t, and another parameter that I want to call s, for example. Okay. Any question? Do you understand very well or not? So in this moment, I present both way. And the book and the other and the video on YouTube show you sliders. Personally, I like projection. Todo bien. I like projection. Entonces, the only thing you need to keep in mind si es vertical projection or horizontal projection. How do you know that? I repeat again the idea. If the segment that I try to find is perpendicular to the vector that I have in my hand, que es the direction vector, entonces you're using cross product. Otherwise, dot product. Entonces es paralelo, ¿no? Es dot product. Okay, super. Let's move on to another topic. I can erase the board. Yes, right? Okay. Okay. Now we study a relationship between two lines. Two lines. So we have two lines. We have two lines. Line 1 and line 2. We can see the whiteboard, Professor. Oh, yes, sorry, because of so you don't see the last part. I explain the formula. You see whiteboard now? Because you don't see in the video the last part. I explained the formula, and the formula I explained in the last part was distance. It's a distance between a line and point. No? Is magnitude direction vector cross AP vector divided by magnitude of P. And you condense it. Entonces, the important thing is that this is vertical projection, not horizontal, because the segment I try to find this is perpendicular to the direction vector. Okay, the only information that is given in the line. Okay. Okay, let's go out of two line connection relationship between two lines. Line 1, line 2. Okay, line 1, line 2. Well, we have three possibilities. A ver, 1, 2, 3 possibilities. Yeah. One possibility is that the line intersecting one specific point. Intersecting. Another possibility is parallel line. By the way, in both cases, in both scenarios, when the lines are intersecting or the lines are parallel, both is containing in the same plane. But we have another possibility. Remember, we have 3D problem, and 3D is more complicated. We have a skew line. Skew. The spelling for the skew is skew, no? Skew, K. Skew. Skew line. Skew lines, no parallel, no intersecting in 3D. So one line travel in one direction, another travel in another direction, but in different plane, and never intersecting. So this is never intersecting, skew line. So how do you know? Okay, we have intersecting line, parallel line, or skew line. I bring example. Professor, you are not recording. No. Oh, carajo. I suppose que yes. No, stop recording. Yeah, it's recording.
Yeah, you're recording.
Yeah, sorry, no. Don't make a noise. I appreciate so much your help, but no, don't make a noise. Pero bueno, sometimes happen when I press accidentally the bottom of the pane. Okay, example to understand intersecting line, parallel line, or Q line. Suppose this example of that part. Okay, this is line 1, line 2. Entonces, what is given? Bueno, it's given the parametric equation for each line. 3 plus 2t. Y is equal 4 minus 2t. And C is equal 2 plus t. This is the set of the parametric equation for the line number 1. And for the line number 2, I suppose that t is a real number from negative infinity to positive infinity. In that case, not always happen, but sometimes happen. So you want to define no lines, sino segment, entonces ellos restriction de domain. Okay. Okay. In order to investigate, see they are intersecting, parallel, or skew. Well, you take equation by equation. You take this equation, and you take this equation. And you put equal each other. Okay. 3 plus 2t is equal 6 minus t. 2t plus t is equal 6 minus 3. 3t equal 3. T equal 1. Okay. And this one it's not super important thing. It's one. It's a number. And you take now the second component, is y. And you put each other equal each other. Wow. Okay, entonces 4 minus 2t equal 3 minus t. Again, the same thing you solve for t. Minus 2t plus t is equal 3 minus 4. This is minus t equal negative 1 divided by negative 1 both sides, t equal 1. Wow. It's no coincidence. T is the same. But if in the third option the answer is t equal 1, that means that these lines are intersecting. See, at least one equation failed and give me a different number. It's because they are not intersecting. It's another thing I tried to investigate in the second part. So now let's take in 2 plus t equal 4 minus t. Entonces t plus t es equal 4 minus 2, 2t equal 2, t equal 1 again. Divided by 2, t equal 1. That means when it's the same, when this is at least one equation give me different t, it's because they are not intersecting. Entonces, by the way, this is interesting to find the intersecting point. And to find the intersecting point, you set any set of the parametric equation and plug it in t equal 1. Suppose que I take the line 2. Entonces es obvio que x is equal 6 minus 1, que 5. Y is equal 3 minus 1, que 4. E2, 4, hello. E2. And z is equal 4 minus 1, que 3. And the point, the intersecting point is the famous point 5, 2, 3. So conclusion, they are intersecting line, intersecting lines, and the point in which this line intersecting is that point. Super clear? Let's see another example que es no intersecting. You understand why it's not intersecting? If it's not intersecting, maybe it's parallel. If it's parallel, so you find the distance between this point using similar idea, no? Similar idea. So far, everyone follow me? Now, suppose que is given another parametric set, line 2 and line 3. Line 2 is the same. There's x equals 6 minus t, y is equal 3 minus t, and c is 4 minus t. But line 3 is different. It's another line that is 6 minus 2t, y is equal 7 minus 2t, and z is equal 1 minus 2t. Okay, because I have no idea. I take the first equation, put equal this, the first equation in the other parametric, set. I try to do my best. Well, minus t stay here, plus 2t equals 6 minus 6. And this is t equals 0. Okay, 0 is a value, no illegal. You take now another case 3 minus t equal 7 minus 2t. Entonces minus t stay here, plus 2t equal 7 minus 3. This is t equal 4, completely different value. No intersecting. Okay. Now, however, to verification, si es parallel or no, take the direction vector of the line 2. Direction vector is the vector -1, -1, -1. Look at that. Look at the coefficients in front the t. And direction vector B3 is -2, -2, and -2. Wow. Look like proportional. Okay, entonces when the situation happens, you know very well that they are parallel. So if you divide, for example, you divide this component divided by this component. It's -2 divided by -1 is equal to -2 divided by -1 is -2 divided by -1, que by the way is 2. That means, obviously, that the vector B3 is 2 times vector B2. Okay, it's multiplication by scalar. You multiply by B2, multiply by 2, you can make B3. So they are parallel, definitely parallel, right? Entonces, this parallel line lie in the same plane, suppose hypothetically. One roughly sketch to understand. One roughly sketch to understand. This is the line 1, the line 2, for example, and this is the line 3. Okay, I prove mathematically that they are parallel. However, I need to find a distance. That distance. To find the distance, we are doing similar idea. Similar, very, very similar. You take one point A1 on the line 2. You take another point A2 in arbitrary position, totally arbitrary. You determine the vector and the direction that you prefer, in the direction, that direction or that direction is not important, the direction. You have here the direction vector B2, and you have the direction vector B3. And you perform cross product. So it's not exactly cross product, it's vertical projection. So basically, I find the vector, for example, A1, A2. In this case, A2, A1. No, A1, A2, A1, A2. No, A2, A1. So always I have problem with to understand this. A2, A1, A2. And the arrow point to it. And in big trouble always with this. A2, A1. It's easy because you find 1 point on the line, 1 point on the other line, and you perform the cross product with the B2 or B3, doesn't matter, divided by magnitude B2, and this is the actual value of this. And this give me the distance D, que es that distance. That distance. The distance between the line. Do you understand the strategy? Entonces, I try to find one point in the line 1, que es super easy. I highly recommend t equals 0. You suppose t equals 0, and t equals 0, you get the point on the line 2, que es el point 6,3,4. 6,3,4. Assumption t equals 0 on the line 2. This is on L2. Likewise, t equals 0. Not necessarily. Another point, t equal, actually it's not t. This is another line to say the parameter is not t, it's s, for example. But it doesn't matter. It's not important. It's totally irrelevant. Suppose s equals 0, and you get another point, get the point 6,7,1 on L3. This is the point A1, no? And this is the point I call A2. Okay. I don't know why I confused the number, but it's okay. Now I try to find the vector A2, A1. Okay, the vector A2, A1 is. Now we focusing, we have 2 points. This is the vector in between 2 points, right? You subtract 6 minus 6 is 0. Comma. 7 or 3 minus 7, que es negative 4, ¿no? Coma 1 minus 4 is negative 3. All right, let me check if I did well or not. You're subtracting A2 or A1 minus A2, A1. So this is 0, it's obvious. This is negative 4, and this is positive 3. Here, positive 3. So you are doing in opposite direction. It doesn't matter. So the only difference is case this is vector is in that direction, or this vector is in that direction. Okay, now the most important moment. You are doing the formula. The formula is you perform the cross product between this vector and the vector B2. And the vector B2 was, I don't remember, negative 1, negative 1, negative 1, no? I guess so. But let me check it out. Yeah, look at that. Yeah. Or this, no important. Of course, you did make a decision using B2, so you divide by magnitude B2. So you use a decision to using B3 when you divide by magnitude B3. Okay. And this is a heavy, as always, arithmetic. Heavy arithmetic, well, but we can use a symbol lab or GeoGebra or by hand, either way. Suppose you are in the jungle and you have no computer, well, okay. So you know how to put a determinant, but I don't want to repeat again in any problem, cross product, because it's the same stupid thing, right? Okay, now the top part is negative 7,3,4 divided by, and the magnitude of this is radical 3. It's obvious, no? Because it's 1 plus 1, square is 1. Okay, now magnitude of this vector is square root 74 divided by radical 3. Okay, is 4.96 something, approximately. Do you understand the idea? Yes or no? Okay. 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 Suppose now is no intersecting line and no parallel line. This is Q. Okay, I have different example, but let me try to select one good. Suppose we have two lines. Line 1. Okay, the set of the parametric equation is, bueno, is 1 plus 40 x equal 1 plus 40 y is equal 5 minus 40 and c is equal -1 plus 50. And we have another line, line 2. And this line 2 is x, y, z. X is equal 2 plus 80, 4 minus 3d. And c is 5 plus t. Let me check it in the other paper. So I copy right or no? In the other paper. What is the other paper? This is the other paper. Okay, okay. Okay, at least the first equation is okay. And the second equation is okay. Okay, I copy right. Suppose I have in one paper, I have the solution using a slider. In this case, I call no t, I call another parameter. Because, well, first of all, guys, I need to prove that they are not intersecting. You know how? And no parallel. Do you know how? See the direction vector is not proportional. So this is classical skew. So I don't want to start from scratch. So you take equation by equation, put equal each other. In this case, a t, you consider t, no s. After I change for s. But what is the idea? What is the idea? The idea is we have two skew line. You prove this is skew. And you take one slider, que t slider, and you have another slider, que is s slider. The parameter s and the parameter. And this is the famous distance. But I need to find when there's the shortest distance, que es cuando es perpendicular here, perpendicular here. Okay, entonces the idea is similar, no? You take, for example, the line 1, line 2, for example, line 2, line 1 vector, multiplication by b1, the direction vector of the first line, equal 0. And likewise, the L2, L1 vector, dot product b2 equals 0. So we have two equations. So who is L1, L2? Bueno, you subtracting in order to form it. You subtracting this expression minus this expression. Let's do it. For example, the component x for the famous vector L2, L1 is, component x is as plus 2 minus, because it's the vector in between 2 points, no? Minus that guy, que es -1 and -40. If you combine, you have AS minus 40 plus 1. And Y is similar. You take 4 minus 3S minus the Y component for the second line, que es 5 minus 40. Entonces, actually is -5 plus 40. We have 40 minus 3S plus 1. Minus 1, sorry. Because it's 4 minus 5 is -1. And Z, similar, is S plus 5 or 5 plus S. It doesn't matter. Minus, que actually is plus 1 minus 5T. Entonces, basically is S minus 5T plus 6. Okay, and this is my famous vector. Okay, and let me write in vector notation. L2, L1 is a vector AS minus 4T plus 1, comma, 4T minus 3S minus 1, comma, X minus 5T plus X, 6. Who is B1 and who is B2? Well, B1 is B1, the line 1, direction vector, is 4, comma, -4, comma, 5. And B2, direction vector is 8 minus 3, 1. Okay, now you take this, perform the dot product. Okay, actually, when I'm doing this operation, I want to save time. I get one equation, and the equation is 49S minus 57T plus 38 equal to 0. So the thing I did was multiplication, so dot product. This times this. This times this. And this times this. And I get this equation. Equation can contain two unknowns, S and T, because we have two sliders. Likewise, you multiply again this times this. This times this. And this times this. And you get this equation, que is different. Is 74 is minus 49T plus 17 equal to 0. Wow. In this moment, I have two equations and two unknowns. This is completely different because when you have two lines, you have two sliders. And you move the slider in order to get perpendicular in both. So the segment distance I try to find must be perpendicular in order to find the shortest distance. Okay, so now we have a system of equations, heavy algebra. Pero no, it's okay. I put in the algebra, exactly I explained, matrix, reduce row echelon form. Yeah, I get the answer. Guys, mathematics not always is pencil and paper. No, software help us engineers to solve the problem. And better than us. You get S equal the weird number is A93 divided by 1870, and T is 1979 divided by 1870. Okay, this is T. Can guarantee this condition? Look here, this T. Wow, weird T. And this is the ST que guarantees this condition. Oh, weird S. Now, in order to find the vector You plug in this S and this T here. You get the famous vector, so you get the X component, the Y component, and the Z component. And you plug in A times this S minus 4. How do you get this S and T? Well, okay. This is no big deal. This is the intermediate algebra, no? You solving two system of equation and two unknown, S and T. Of course, I don't do by hand. It's the thing I try to explain. I put in algebra using matrix, and I apply reducer row echelon form. Got it? Got it? This is okay, guys. See, you prove that 2 plus 2 is equal 4 anytime you want to add in. You never finish. So you, in order to focus in the important part is the geometry in 3 dimensions. And so you in the middle of the process, you find a monster. Wow, system of equations. Entonces I focus in the algebra and you lost concentration, and when you come back, you remember anything. So my recommendation is using software to solve this. Okay, now, but it's okay. This by hand is no big deal. Consuming time, but no big deal. Now, you plug it in. The important is this is X of the vector. This is Y of the vector. And this is C of the vector. I want to call this. I'm plugging in T and S in each expression one by one. And you get that number. Is I want to copy. Okay, finally, so you want to find the magnitude of this vector. You apply square root this guy. Square root this guy. Magnitude of this vector. Big square root of this plus this square plus this square. And the answer was 95 divided by square root this number. And this is approximately 2.22, 2.2286, 2.2. However, this is a slider method. In this case, complicated, huh? Because you have two sliders, T slider and S slider. Okay, another possibility is projection. Do you understand the slider? Entonces now, what is the disadvantage? Disadvantage the heavy algebra, no? But it's no big deal. Look at that. What should I do? When you subtracting component by component X, Y, and Z, because you find the vector L2, L1. It's that vector. Let me using one color to emphasize this vector is this vector. It's a vector in between 2 points of the line. Now you perform two dot product because I want to find the perpendicular position in both lines. You solve the system of equation. This is nothing for us, guys. And that's it. Another possibility. Using projection. Let me try to explain. Do you follow me? Any question you have? No question. Of course, you need to practice, no? You need to practice. It's not the problem. The problem is to understand the concept, the idea. So in this case, no formula. Professor, no formulas. Yeah. I want to explain the projection. The projection is a little bit more clear. At least for me, this is completely, it's up to you, no? Let's see projection. The projection is, Okay, basically, let me see. Again, we have two lines. By the way, we are doing the same problem, line 1, line 2. We have one vector here, direction vector B1, and direction vector B2. I try to find the shortest distance here, in between what is perpendicular here and perpendicular here. Okay? Okay, entonces I propose one idea. Actually, in 3D, this is, the sketch is not 3D, so it's a little bit hard to understand. Basically, you have, let me try to do my best. So you see a floor plan of this is my eyes. I see this line, for example, like this. This is line 1. And I see this line like this. Line 2. Actually, it's not intersecting because they are living in different plane. But the problem is that this is B1 vector and this is B2 vector. Okay, pay attention. This is complicated to understand. Now, I try to find the cross product. Cross product, according to the, for example, B1 cross product B2. And B1 cross product B2 is a one vector according to the right hand side. It's a vector que, bueno, es perpendicular to B1 and B2, but is get inside the board. According to the right hand side, remember the convention que we are using the vector. Suppose that the vector is an arrow. We have here this symbol. So you see in this direction, you see like that, boom, like a circle at one point. However, so you see in that direction, this is my eyes again, you see like that, boom, boom. In this case, it's B1 cross B2, entonces the vector cross product is in this direction, point, right? B1, B2. And this vector is perpendicular, totally perpendicular because it's in that direction maybe. Totally perpendicular to the segment that I try to looking for. The segment is, you know, is in between two lines. Therefore, you apply, for example, a dot product in between one new vector. For example, I select here 1.A1. You select here another point A2. You can find a vector in between two lines. Similar idea that we are doing in the slider. But now you perform the dot product between this new vector que es perpendicular to the segment that I try to find. Entonces es perpendicular, no, es parallel. Therefore, the formula is B1 cross product B2 divided by magnitude B1 cross product B2. This is the unit vector. Unit vector que es perpendicular to the both direction vector. And you perform now a dot product with the vector A1, A2. And give me scalar. And this scalar is that distance. Okay. Let me try to explain using my hands. Okay, stop sharing. You see my face now? You see my face? Face. Yes. Okay. You have two lines. Okay. It's skew. Skew is not in the same plane, no. And never intersecting. Skew line. I have in my hand the direction vector of this line. I have in my hand the direction vector of this. you take both direction vector and you perform the cross product, we get a new vector. I don't care the magnitude, que es perpendicular to this. O sea, ves, okay, this is my skew line. Look at that, Q, and you have one vector here. This is cross product. And between B1 and B2. And this is parallel to the segment I try to looking for, que is the shorter distance in between this. This is the distance I try to find. And the cross product is parallel. So you want to find the projection, because I want to find this segment, is using the dot product between the unit vector of the cross product that the arbitrary vector que contain both lines, que es A1, A2. Do you understand the idea, or it's complicated? I know it's complicated because anytime I explain this, the students don't understand very well. No? It's complicated or it's easy, you follow me, totally lost. The geometry part, at least the geometry. Let's see the algebra, the arithmetic part. This is another thing. But the geometry part is clear or no? No? Come on, answer me. Be honestly. Yes, okay. Okay. Entonces, keep in mind, guys. Projection. We have two projections, horizontal and vertical. How you find horizontal? When the segment that you want to find is parallel to the vector I have in my hand. I have in my hand a vector. How you find this vector, I have no idea. In this case was cross product. So you have two direction vector. I perform the cross product. And this vector is parallel to the segment I try to find. Now another dot product. So cross product to find the new vector, univector, and dot product with the arbitrary vector in between the line. Super. And the point and line was different because in the point, and the line, we have one vector here, but we have another vector here, que is direction vector, and the distance or segment I want to find is perpendicular to this vector is given. Therefore, I apply a vertical projection, and vertical projection is cross product. Well, actually, you say, well, professor, you apply both in this problem. Okay. You apply, first of all, a cross product in order to find the auxiliary univector that we need to project in. After that, you find A1, A2, que is a vector in between 2 points on the line and on the both line. And finally, we are doing the dot product. Okay. Let's doing exactly the same example that we are doing before using a slider, and you find your own conclusion. What, in your opinion, is the best way? I have my opinion, no? But I respect any opinion. Okay, so B1, remember the line is given. Let me copy in the vector notation. Line 1 is 4, -4,5t plus. No whiteboard. Again, my face, I suppose. Unbelievable. Now, yes or no? Yes or no? Okay, good, very good. Yes, okay, super. So I have the line 1, okay, I don't know why in the paper I write in vectorial format. It doesn't matter, or parametric. In this case, clear, this is the vector B1. And the other is 8, -3, 1t plus 2, 4, and 5. Okay, super. To say you, first of all, identification, wow, vector direction is B1, B2, and you perform B1 cross B2. because there's the auxiliary vector que help me to projecting. Okay, entonces we're doing IJK, 4, -4, 5, 8, -3, and 1. Boom. Do it by hand using software. The answer is 11, 36, 20. Okay. Now I find the magnitude of this cross product. Is square root 11 squared plus 36 squared plus 20 squared. And the answer is square root 1870. Okay, no problem. I understand. Now I need to find the point A1, A2. Well, the point A1 on the first line is 1, 5, -1. Where come from that? Well, remember the equation. This is this. This is like a vector, no? And this is like a point. Under the assumption que t is 0. Or t not necessarily 0, guys. Any number. And this is s or t. It doesn't matter. Entonces A2 is 2, 4, and 5. Now we found the vector. Okay, it doesn't matter. I call A1, A2. Okay, you're subtracting. It's vector in between 2 points. It's 2 minus 1, 1. 4 minus 5, -1. And 5 minus 1, be careful with the sign. 5 minus 6, right? 6. This is the same idea that we studied the first day. It's a vector between 2 points. You're subtracting the component and the guy que have the arrow, que hay A2, the 2 minus 1, 4 minus 5, and 5 minus 1 is 6. And now you perform dot product, because I know very well que that vector is parallel to the segment I try to find. Okay, so you perform dot product between, doesn't matter, the dot product is completely commutative, so it doesn't matter the ordering. Is 1, -1, 6, dot product 11, 36, 20, and don't forget divided by magnitude of the cross product is square root 8,870. Okay, let's doing. This is easy. This is the 11 times 1 is 11. Minus 36. Because is 36 times -1 is minus 36. Plus 120. 120. Yeah. Unfortunately, in the real life, the problem is horrible. That is the reason that we use a calculator, we use software. So you are doing by hand, you never finish. Let's say this is 95 divided by this, gets exactly the same answer that we obtain in the slider method. Same answer. But I prefer that way. I don't know you, but I prefer that way. Okay, let me condense the information so far of the lines. Okay, and let me summarize and put the formulas, the most important formulas. Suppose we have 2 lines. The first line, line 1, is in vectorial way. A1 plus B1T. And the line 2 is A2 plus B2. Entonces, bueno, you immediately you try to prove que es intersecting or no. This is easy. Is put equation by equation, so you get the same T. Entonces es intersecting. Okay. Otherwise, no. Ahora, suppose que you perform a cross product B1, B2. And the answer is 0. Entonces es paralelo. Es paralelo. O proportional vector. So you get que B1 cross B2 es no zero. No zero vector. Entonces es Skew. Skew line. The formula for the parallel, que es when the B1 cross B2 is 0, is easy. You take 1 point on this line, so suppose this line parallel. You take 1 point A1, you take A2, you form a vector. The direction is not important. And you perform cross product. We're using B1 over 2 because, by the way, they are proportional and divided by magnitudes. Of course, actual value this and give me this. Boom. Oh, skew, no. Skew is more complicated. Skew is when you identify first. You see que the cross product no 0. Entonces es skew. Entonces, the cross product is no 0. Well, you take the direction vector of each line separately. You perform a cross product and you divide by magnitude of this cross product. What are you doing? Well, using unit vector. After, similar idea of this. You take the unit the vector in between 2 points on the line and perform dot product. A1, A2. Boom. And give me the system in between the line. Super cool or super complicated? Cool or complicated? All right, that's the problem. What's the answer? Oof. What's going on? Okay, good. A ver. Opinion, guys. Cool? Okay. Now, let me try in the 5 minutes that we have, not too much, pero anticipate the new thing we studied last time. Well, last time, we have a point. Do you see whiteboard, right? Okay. And we have a plane. We have a plane and point. I need to find the shortest distance. Okay. After we conclude with the formula, no? But I try to understand the idea. Okay, the coordinate for the point, suppose it's X, Y, and Z. But this is always given. This is always given. Now, I want, well, this distance is perpendicular, no? Shorter distance. I can find 1 point on the plane. This is the plane. Okay, this point I want to call Q. I don't know why. I like the Q letter. And you find the vector in between 2 points. Doesn't matter the direction, si es from Q to P or P to Q. Okay. What information? Remember, to define a plane, the piece of information that we need is a point and the normal vector. Normal vector is completed arbitrary No necessary unit vector. No, no, no. No necessary unit vector. Pero es perpendicular to the plane. Okay, this is important. Entonces, when you see the equation of the plane, automatically you see normal vector is, for example, ABC, que is the coefficients in front, X, Y, and Z, in the equation of the plane. And we have in our hand the coordinate, the component for this point, que I want to call X null, Y null, and Z null, right? Therefore, I compute immediately the vector in between 2 points, QP. Okay, QP would be X, let me call 1 here, no, not generical, 1, Y1, C1. It's X1 minus X null, Y1 minus Y null, C1 minus C null. And also, okay, the segment I try to find is this segment. And what is the related position of this segment, que es D, no? The distance, the shortest distance, no? And the normal vector. They are parallel or they are perpendicular? My question was, the position of the segment D, que I highlight in blue color, compare with the normal vector, que is the vector que I have available in my hand because it's given for the plane. What is the relative position? They are parallel or they are perpendicular? Parallel or perpendicular? No, perpendicular. But the blue segment is perpendicular to the plane. But my question was, this blue segment with the normal vector of the plane is perpendicular or parallel? It's parallel. Therefore, in order to find the shortest distance, you find projection. But what kind of projection we using? Horizontal projection or vertical projection? A ver, this is important moment. Vertical projection. No, David dice vertical projection. No, horizontal. Because you projecting the vector QP onto the direction M. Because I want to find D. Entonces es in the same direction. Entonces es horizontal projection. Do you see or no? Okay, if you find the horizontal projection of the vector QP and the direction of the vector M, normal vector, is the distance D. Of course, you find the actual value, no? So the magnitude. Do you understand the idea? This is complicated to see, I know. Well, at the beginning, no? After, when you take your side, you see, you eyes to this situation, entonces now is okay. Remember, you have a vector, you want to project in this direction, because I have information about this vector, to say it's basically horizontal projection, yes or no? And vertical, no, vertical is perpendicular. In this case, I need to find this segment, and this segment is parallel to the normal vector, que es the vector que I am using to perform dot product, no cross product, because of horizontal projection. Okay, let's do it quickly. Quickly, we have only 1 minute. Is QP dot product M. Of course, divided by magnitude. Remember, in projection is unit vector. So you find the unit vector and the direction of the, let me use unit vector in blue color. This unit vector of M, no? This is the idea. And that's it. And not necessarily magnitude here because the dot product is a scalar. And the formula I explain next time. Okay, next time I explain the formula. Guys, Please, I appreciate so much. This is complicated, you know. Do you believe it's complicated, right? So now, Emiliano dice thank you. I appreciate so much that you don't waste the time, because the time is summer, you know. It's a big complicated, no? And this is just David, and this is just the beginning. I promise that this is crazy. Because I don't understand some students can say, no, calculus 3 is easy than calculus 2. Calculus 2 is nothing. Calculus 2 is algebra. And some formulas, some, but this is involved a little bit, not weird, but hard concept that you need to introduce little by little in your brain. But this is important, guys. In engineer major, you need to take every subject related by calculus 3. The most important is fluid mechanics, electromagnetic. Everything is vector, 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 vector field, vector field. Get the last part, vector calculus. Because it's important that you understand the thing in 3D, right? Next time we continue with the plane and the distance between point and plane. And after we study distance between plane and plane, and after we study the distance between plane and line. And after that, we study surface. And we almost finished chapter 1. Chapter 1 is super complicated. Well, I don't know, a little bit. Okay, guys, I love you. Have a nice day. And I'm leaving, I have another class. Okay.